So we know that in yesterday's class we studied production of sound and as well as propagation of sound. So sound will only produce by what bodies? Everybody. Only by vibrating body. So if the body will vibrates only, it will produce the sound. If there is no vibration in a body, if any body is producing sound means definitely it is vibrating. So vibrating membrane or vibrating surface or vibrating object only can produce the sound. So now this vibrating body is as to produce the sound, but the sound needs to reach the receiver or the listener, whomever it is. So for the traveling of sound, sound always needs medium to propagate the sound. So if the sound needs to propagate from one place to another place, definitely it needs either solid medium or liquid medium or gaseous medium. So through any medium only it can travel. If there is no medium, if no medium is available, understanding, then no sound can be audible. No sound can travel. So that is the problem with the sound. But if you take the light, light can travel with or without medium. Light can travel with or without medium, but sound can travel only in the presence of some medium. It may be a solid medium, liquid medium, or gaseous medium. That's why we will say sound is a what waves actually. Sound waves are a something waves. Yesterday I told you, on day before yesterday also we studied. Yes, please. You need a medium.
Mechanical waves.
Yes, mechanical waves. The waves which we need a medium to propagate, they used to call it as mechanical waves. That's why sound waves are mechanical waves, we can say. So, even class 8, you will be having the experiment that prove that sound cannot travel through the vacuum. So there is a bell jar putting inside the vacuum that inside a glass container and removing the air pressure. So like many things, but of course it is not needed in ninth class. So but it's fine. You remember, sound cannot travel without medium. So sound only can travel under the presence of some medium. So now sound can travel with a maximum speed in solid mediums and minimum speed in air medium. So are gases. So now if you take the speed of sound in air, basically the speed of sound in air, which is equals to 340 meter per second. This is the speed of sound in air. Suppose if you take the same speed of sound in metals, for example, if I take iron, understand? It will travel almost like 1500 meter per second. So in which one it is traveling faster? Everybody. Yes, please. Solid. So
Yes.
sound can travel faster through the solids compared to the liquids and as well as gases. So that is one of the important points. So please all of you remember. Anybody having any doubt? Please ask me. Or else we'll proceed. Clear everybody? All of you?
Yes, sir.
So now, next we are going to study characteristics of a sound wave. Please write it. Characteristics of a sound wave. So today's class, we are going to focus on this only. So first thing, wavelength. What is the symbol? Lambda. Second one, amplitude. Again, 11th class, everything is going to come. Keep it in mind. Third one, time period. Time period. Fourth one, frequency. So till 8th class, you will study what is the symbol for frequency. Anybody? Frequency symbol. Nobody knows? F. Of course, ninth also you can study F only. Nothing wrong in that. But if you go to the 11th class, the symbol for frequency is there is a small change. But many people won't be believe. That's the reason I will show you and I will make it. So the symbol for frequency in class 11th is V. Not stylish V, small V it is. So you all can see that. So this is the symbol for V in the class 11th. Chapter name is oscillations. You all, so you are convenient, but when you are representing, you please respond, write it. Let the frequency of the periodic motion. It is represented by the symbol V. This is the symbol for frequency in class 11. Or you can write F also. F is equals to 1 by time period. Or we all know time period is equals to 1 by frequency relation. So you can write anything. Just I am saying you both have a possibilities. So even you can see the example 1 is related to time period and frequency only. So exactly. So that's why it says all the concepts are going to come again with along with the continuation and as well as derivations and all will be there like advanced level mathematics there. So now, as we know that sound is a what wave? Longitudinal wave or it is the transverse wave? Everybody? Sound is a what wave, guys? After studying everything, don't know this one alone. Yes, please. Sound is a what?
Longitudinal wave.
Longitudinal wave. It is a longitudinal wave because it will travel how? Through the air or solids, everything. Only through a parallel vibration. No perpendicular to the motion. So parallel only. It is a longitudinal wave. So now we need to study what is the wavelength, amplitude, time period, frequency, and the last one, most important thing, that is what? Speed of a sound wave. This is only the numerical part and the very, very important part. That is what speed of a sound wave. What is the speed symbol? Anybody? Already from last 3-4 chapters we are studying. Speed symbol, stylish V. Okay, V, stylish V, or that is what speed of a sound wave, or we can say is wave velocity. Somebody said wave velocity here, Sanjay. Yes, Sanjay. Velocity of a wave or wave velocity. Okay. So wave velocity. So velocity, when you are speaking, definitely you have to put the arrow because velocity means it will speak about the what? Direction. Am I right, everybody?
Yes.
Yeah. So that is what you have to remember. Now, frequency, your choice. I don't have any problem. So you can choose F or you can choose V. But this V, no bending. So this is the symbol for V. Okay, everybody. So now let us start with the characteristics of a sound wave. So we all know it is a longitudinal wave or it is a transverse wave. Everybody. It is the longitudinal wave. But we have been learned that longitudinal wave can be converted into transverse wave to study the properties in a better manner. So that is what we studied. Compression is considered as something. Anybody?
First,
Compression is considered as crust and rarefaction is considered as a what?
rough draft.
I am drawing a now what wave? Anybody can tell? I am drawing a
Longitudinal wave.
longitudinal. Okay. So compression followed by rarefaction, compression followed by rarefaction. This is the wave which we used to call it as longitudinal wave. So now to study all the properties, it is not easy. So we are studying converting this longitudinal wave. We are considering into what? We are considering into what, guys? All of you. Yes, please. Density or pressure and sound wave. Sound wave versus density. We have drawn yesterday also graph. There is a graph. You all remember that? Density or pressure versus distance graph. Do you remember? I want response.
Yes, sir.
Yes. So what is a
Yes,
graph?
sir.
That is only we'll consider. So density or pressure this side. Density or pressure if have been taken and distance graph. So now tell me where the density is maximum at compression or rarefaction?
Compression.
Compression. Understand now?
Compression.
Please learn it. Any doubt, anybody can ask me. Compression followed by rarefaction. Compression followed by rarefaction. So let me take it. Okay. So till here I'm considering the wave. Clear, everybody? So now this is the point where we're having maximum density or minimum density.
Maximum density.
Maximum density. Okay. So that is what? So that is the maximum displacement, which we used to call it as something. Anybody can tell? No need to waste time with the definitions. What is the maximum displacement we used to call it as?
Amplitude.
Amplitude. Either in a rarefaction or compression, whatever it is. Maximum displacement, which we used to call it as a what? Everybody? Amplitude. Please write it. So on this point is what we used to call compression or rarefaction? Yes, please. All of you? Rarefaction. Okay. So you can make it. That is what. So maximum displacement of a wave anywhere, that is what we used to call it as amplitude of the wave. So any doubt, guys? Please respond. All of you?
Yes, sir.
Yeah. Next, second one. So what is the symbol for amplitude, everybody? Yeah. Next. Clear, understand, Amma? So the maximum displacement of a particle from its what position? Anybody?
Mean
What
position.
position? Yeah, this is call it as a mean position. This is call it as an extreme position, and this is also call it as extreme position. So that is what you have to remember. So amplitude means the maximum displacement. Maximum displacement of a particle from its what, guys? Everybody? From its
Position.
mean position, which is call it as amplitude. So that is the meaning of amplitude. Is it clear, Mr. Kishore, Lingesh?
Yes, sir.
Yes. Do it. Sangamitra, understand Alfin?
Yes, sir.
Make it fast. Completed? Nivedan?
Yes, sir.
Next. Next, second one. So first one, amplitude finished. Next. So let us consider first one, wavelength. So wavelength means, so remember, I will say you, that's what I'm saying. So first one I'll consider as a, let me consider as a crust, or this is also is to say second crust, and this is I'll consider as a third crust. Same way, this one I'll consider as a rarefaction, or I can consider as a what? Trough. I'll consider as a what? Trough. So now, all of you remember, everybody, this upper region I used to call it as, okay. Mari, are you there? Where is that? I not seen Mari. Okay, now only came. Okay, that's fine. Yes, Mari. So okay. So now upper part, which we used to call it as, basically what we used to call, guys? Upper part we used to call it as compression. Lower part, what we used to call, everyone?
Rarefaction.
Rarefaction. Again, this one what we used to call, everybody?
Compression.
Compression. This is what we used to call
Rarefaction.
again, this one what we used to call compression. So always one compression is followed by rarefaction, and again another compression again followed by what? Rarefaction. So always one crust is followed by rarefaction, or trough, like we can say trough is considered as a rarefaction, and crust is considered as a compression. So now wavelength means, please remember, the distance between the two successive crust. Successive means side by side. The distance between the two successive crust, which we used to call it as wavelength. What is the wavelength symbol, everybody?
Lambda.
Lambda. Now, or second and third. This is also call it as what? We used to call it as, everybody, wavelength only. Do you all understand, guys? Please respond, guys. Everybody? I want response.
Yes, sir.
Yes. Or, see, wavelength, many definitions. People learns anything. Now, distance between the two successive trough is also called it as a what? Wavelength. Do you understand? Either two successive crust or two successive trough is called it as a wavelength. Or there is another definition, another representation. If you observe very carefully only you can understand. Now with the green color I am representing. Exactly midpoint of compression and another midpoint of compression. Now you measure it, definitely it is also same only. Am I right or wrong? Everybody? That's only we studied. Yes or no? Distance between the two successive compressions. That is what is called it as a what? Wavelength.
Wavelength.
Now, or you can take. Generally, what do you mean by one oscillation? One oscillation means what, guys? Anybody? One oscillation. What do you mean by one oscillation? Anyone?
A single to and fro
Yes.
motion.
So like one compression followed by one rarefaction. This is called it as one oscillation, or we'll consider as a what? One wave. Understand, Amma? So one oscillation means one compression followed by one rarefaction. That is what we used to call it as one wave or one oscillation. So this one wave, the length of a one wave is also called it a, that is what, starting point of a wave and ending point of a wave. That is also called it as a wavelength. Clear, everybody? All of you understand? Please.
Yes.
Yeah. So this is the starting point of a wave, and this wave is ending where? Going and coming and again going. So up to here. This is also called it as a what? Everybody? Yes, please. That is also we used to call it as wavelength only. Do you all understand? Please respond, guys. Everybody? Nobody?
Yes, sir.
Wavelength means the distance between the two successive crust, any two successive crust, or any two successive trough, or the starting point of a crust and the ending point of a trough. That is what we used to call it as wavelength. Any doubt, anybody can ask me, or else you can proceed. Clear, guys? All of you?
Yes,
Any
sir.
doubt? That is what. So please make it definition. Wavelength is the distance between two consecutive compressions. Consecutive means what? Mathematics. What do you mean by consecutive, guys? Side by side compressions are the distance between two consecutive rarefactions. Either compressions or rarefactions. That is what we used to call it as wavelength. Hope you all understand. Anybody having any doubt, please let me know, or else wavelength clear means then we'll go with the amplitude and wavelength over. Then we'll go with the time period. Shall we start, guys?
Yes, sir.
Yeah.
Sir.
Okay. All of you?
Yes, sir.
Next, time period. So time period means, this is very, very important. Time taken to complete one vibration. Just now I said. So what is one vibration, everybody? What is one vibration or one oscillation? Please. One vibration or one oscillation or one wave. Everything is same. One wave or one oscillation. All the things are same. Anyone?
On compression on rare fraction.
One oscillation means what? One compression and one rare fraction is called as a one wave. Or one crust and one trough is called as a what? One wave. So the time taken to complete one oscillation, the time taken to complete, here time is 0. So the time taken to complete one oscillation is called as, what is to call, everybody? Time period. Okay, so that is what you have to remember. Write it. The time taken by the particles of a medium, the time taken by the particles of a medium, the time taken by the particles of a medium, the time taken by the particles of a medium to complete how many vibrations, everybody? How many vibrations? One vibration or one wave or one oscillation. Anything it is. Clear, Agalya, Alfin? Anything, either one vibration or one oscillation or whatever it is. That is what wish to say. Clear, everyone? Please respond. All of you?
Yes, sir.
So now SI unit. SI unit of time period is seconds. And I forgot to mention you, SI unit of amplitude is also meters. SI unit of wavelength is also meters. Please mark it. Anybody having any doubt, you can ask. Okay, wa? Elame, understand? And one more thing I want to ask you people. That is what? If, check it everybody. This is also very important. Please note it. Now, if distance between the two successive crust from here to here, what is to call it as, everybody? What is to call? Please respond. Wavelength. Because this is the crust and this is the crust. Now, distance between crust and followed by immediate trough. Anybody can tell, or rare fraction, whatever it is. What is this? Anyone? How much distance?
Wave.
Half of the wavelength. That is what? Lambda by 2. Do you all understand, Ra? That is only very important, Ra. Please respond, guys. Are you clear?
Yes, sir.
Then this is also how much? This is also lambda by 2 and this is also lambda by 2. So lambda by 2 plus lambda by 2, which is equals to what? 2 lambda by 2, which is equals to how much, Ra? Lambda. Do you all understand, guys? That is what. So the distance between the compression followed by immediate rarefaction or crust followed by trough. Understand, everybody? Crust followed by trough, which we used to call it as a what? Anybody? Yes, please. Half of the lambda. Clear, everyone? All of you?
Yes.
Yeah. That is also very important. That's the reason I'm mentioning it. Okay, guys? So this is what time period. So time period means what? Time taken to complete how many oscillations?
Oscillation.
One oscillation, one vibration. Meeting is going to end. I'm sending the link. Join back and we'll finish the frequency and speed of the wave. Make it quick. Any doubt, guys?